We know that if it exists, technological civilization is rare in the universe. But if they do exist, what might our cosmic cousins be like? Obviously, it's a little bit foolhardy to try and think up what aliens might be like. The unknown is reputed to be pretty unpredictable, and most predictions about it tend to fall through. Additionally, in my observation, most of even the best alien concepts in science fiction, the holy land of scientific speculation, are actually rather anthropocentric, and more alien things can be found right here on Earth. To imagine what a real alien civilization might be like, how they look, how they act, and how they think, is a very difficult undertaking. Failure to make solid predictions is assured. So, let's try it anyway. My name is Keegan Van Hook, and this is Crossed Signals.
Nowhere to be found.
It descends and receives radio signals.
Nowhere to be found.
But it's so large and powerful that it could communicate with an identical radio telescope 15,000 light years away, halfway to the center.
Nowhere to be found.
To search for signals from civilizations in space, and just once, to broadcast a message to a distant star cluster called
Nowhere to be found.
But is there anyone out there to talk to?
Tell me, do you think there is life on other planets?
Well, I'm not quite sure, but I suppose there would be.
No, he seems definite. You seem
Definitely.
definite. How do you see this life and where?
Oh, I've seen a flying saucer.
You've seen one?
Yes,
Where was
definitely. At Lane Cove,
When was this?
1953.
You don't think this is a figment of your imagination?
Several other people with me saw it.
You all had the same figment. What did it look like?
It was standing up there, still,
Just suspended in space?
with colours coming out of it.
Flat or on its side?
It was around.
And you think this was sent from another planet, do you?
I really do. Well, where else would it come from?
Wild speculation into the unknown is not a very scientific way of trying to find answers. That being said, there are certain frameworks through which to hypothesize alien civilizations that are actually quite useful to science, as they focus on the detectability of the civilization and aid in describing, on a broad level, the kinds of things we might want to look for. Chiefly, there is the Kardashev Scale, named for its creator, Nikolai Kardashev. The Kardashev Scale has been the most popular classification system for hypothetical alien civilizations amongst SETI researchers for well over 50 years. The Kardashev Scale takes the approach of being rather vague, describing civilizations only in terms of the amount of power they utilize or are capable of utilizing. The Kardashev Scale contains 3 classification types. A Type 1 civilization is a civilization which uses the entire potential power output of their home planet. A Type 2 civilization is one which uses the whole power output of their home star. And a Type 3 civilization is one which utilizes the power of their whole home galaxy. That scale may strike you as being unbalanced, or you may think it jumps too sporadically, as others have suggested as well. However, the types within the Kardashev scale are useful because it gives us a way to describe civilizations we might find in terms of their impact on the physical universe, which in turn impacts the way we might detect them. Of course, there are reasonable criticisms one could have for the Kardashev scale. In its broadness, it leaves a lot to be desired when it comes to describing more specific hypothetical aliens which we may eventually face. The gap between a Type 2 and Type 3 civilization is immense, and there are countless aliens which could fall between those classifications. there is reason to desire a finer degree of classification in the Kardashev scale, especially considering that Earth civilization has still not achieved Type 1 status. The go-to way to do this is to just add a point X to the end of the type class. For example, a civilization which controls not only its entire home star system, but the power of several star systems, might be labeled a Type 2.1, or something in that ballpark. On this version of the scale, humanity appears as a Kardashev Type 0.7 civilization. The Kardashev scale does a great job in aiding with the description of possible alien civilizations, but power usage is not the only thing which might define a civilization. It is theoretically possible for a civilization to be very powerful and present in the universe without actually being on the Kardashev scale. It's reasonable that a culture may choose not to expand endlessly into the Type 3 category, and clearly there are not typical Type 3 civilizations present in the universe today. Some civilizations may colonize inwards instead of outwards, building basement universes for themselves to exist in, either in virtual realities or even more magic tech pocket dimensions. Of course, it's possible that certain cultures may not choose to expand on technology at all, a fine Fermi paradox theory, but such civilizations would not be detectable through contemporary means. Researchers like John D. Barrow suggest additions to the Kardashev scale which better describe a civilization's ability to do things like create basement universes. Barrow suggests adding a typeset which reflects a civilization's control over the microscopic world rather than the macroscopic world. This micro-Kardashev scale uses 7 type classes and goes as follows. A Type 1- civilization can control objects larger than themselves, mining and erecting buildings. Type 2- civilizations are capable of gene alterations and biological modifications. Type 3- civilizations are able to control things at the chemical level, forming new molecules and materials. Type 4- civilizations are able to manipulate the atoms one by one, create nanotechnologies, and even complex artificial life forms. Type 5- civilizations can modify the atoms themselves. Type 6- civilizations are able to manipulate the fundamental particles which build up the universe itself. Finally, there is the Type Omega-, which is capable of manipulating the fabric of time and space. On this scale, humanity falls as a roughly Type 2- civilization, with some progress in the area of becoming a Type 3-. While taxonomy is important, even in this fringe hypothetical science, it does not account for possibilities which lie beyond predictability. All of the classification systems we just discussed pretty much assume that life in the universe follows a model of life bearing intelligence and intelligence bearing civilization. However, there is no evidence to suggest that this is the only way. We have to accept that there may be living systems which are characterized by completely different chemistry, or even non-chemistry. Clouds of interstellar dust could technically coalesce by sheer chance into an intelligent being, but it would not necessarily be alive by current definitions. A good all-around definition of life would be anything which seems to resist the natural thermodynamic entropy of the universe. All things in the cosmos are slowly winding down to a point where there will be no more motion and no more energy. But living systems seem to fight this inevitable process through the act of creative organization and resource conservation. Living things, from ants to technological civilizations, bring magnitudes of order to a universe falling further towards chaos.
Do I think there's life on
Yeah.
other planets? No.
Why not?
Oh, I don't know.
You don't think we'll find anything when eventually we land on Venus?
I don't think we'll find life.
What do
We
you think
might
we'll
find
find?
very interesting things, though.
Such as?
Yeah. Oh, I couldn't really say what as. I don't know. But I dare say it'll be something worth knowing.
So, we know what we might be looking for, if only barely, and now the question becomes, where do we go looking? Until recently, most searches have been a shot in the dark, with very little understanding for the landscape of the universe. But, in the past few decades, humanity has gained the ability to locate and track the planets which orbit other stars, and this gives us a major new advantage in our search for extraterrestrial civilizations. Exoplanets are the best place to focus our search for signs of alien civilization because planetary bodies are, in our understanding, the most likely place in the universe for life to appear. While knowing about exoplanets allows us to focus our listening for alien radio signals on star systems we think have a better chance of supporting life, it also gives us other ways to go about looking for signs of life through more direct observation. Astrobiologists want to look for life on other planets by searching for biosignatures, the signs left by living things which indicate their presence, such as oxygen existing in a planet's atmosphere. Researchers concerned with the detection of advanced alien life are on the outlook for technosignatures, the signs left by technological civilizations. This form of searching can be labeled artifact SETI. Something which is possible using only modern tools is spectroscopic analysis, which allows researchers to observe the chemical contents of the atmosphere on an exoplanet by measuring how the light is bent and shifted as it passes through. This is how we might detect oxygen produced by plant life, or pollutants produced by technology on other worlds. With even better detection tools, we might be able to read the waste heat put off by civilization's industry, or see the illumination of their city lights on the dark side of planets. The most startling possibility of artifact SETI would be the discovery of a megastructure. Physicist Freeman Dyson suggested in 1960 that a hyper-advanced alien or future human civilization might choose to gather massive amounts of solar power using a star-encompassing solar array. This is popularly referred to as a Dyson sphere, and in its most basic form is a massive sphere which encompasses the entirety of a star, though more practical designs have since been proposed. This is one of the most classic examples of the kind of structure that a Kardashev Type 2 or Type 3 civilization might build. Such structures would not only be fantastic power collectors, but also very efficient beacons, as the dimming to the star would be noticeable throughout the entire galaxy and even beyond. Other possible megastructures include large space habitats, massive shields, or even the debris rings created by an intelligence-caused cataclysm like Kessler syndrome, where a collision between two artificial satellites causes an increase in space debris, which in turn causes more collisions and more debris. Observers might see a system suddenly fill up with a dust cloud of junk, perhaps indicating the presence of a society which just had a major incident. Accidents and ruin of all kinds are a good way to look for civilizations, as all the currently known civilizations in the universe, the one present on Earth, are quite fond of destructive activities like war. The trickiest thing about trying to establish contact with extraterrestrial intelligence is that we don't know if they are also trying to establish contact with us. If you assume that, yes, they are looking for us, then exoplanets become shelling points for establishing contact. Named for the game theorist Thomas Schelling, shelling points are mutually obvious locations inside the game space for players to congregate. The game of trying to find each other in the universe is very similar to trying to find a friend in a city when you don't have any contact with them. The best you can do is guess at the meeting location and time until you stumble upon them. Of course, there are some locations much more likely than others for you to meet your friend. Jason Wright suggests that exoplanets and particular transit times are shelling points where we might meet our alien neighbors. With exoplanets becoming easier to find, the question becomes when we should look for signs of intelligence. Time is as much a factor in the search for extraterrestrials as space is, perhaps even more so. Certain significant cosmic events may be considered temporal shelling points. A possible example could be something like the periastron and apastron of a binary star system, which could be considered a significant moment in the universe, as it happens rarely but regularly in each system. We could also potentially choose to beam our own signals to an alien star system at the moment our planet would be transiting in front of the Sun from the perspective of that target star. Such transits of planets are times of high alert when civilizations, including our own, ought to pay special attention for signals or beacons. In the cosmos, communication is a blind game. Everyone is alone in the dark, faced with the choice to stay quiet or shout out into the forest. You don't know if there's anyone there to answer, but if there is, you don't know who.
In your opinion, do you think there is life on other planets?
No, I hope not,
Why do you hope not?
because they'd be frozen to death.